I learned from the best. Every day, so that this
oxygen at 7.5 kmq of methane according to the following equation. So we have the equation of reaction here, combustion of methane. A is 3.75 kmq, B is 7.50 kmq, C 15.0 kmq, D 30.0 kmq. So we are looking for the volume of oxygen and the volume of oxygen required to burn this volume of methane according to the equation. So the first thing look at methane equation. So for methane, the molar volume 1 mole is equal to 2.4 kmq. That's standard under standard condition. Now we have to find the number of moles of methane. So x mole is equal to 7.5 kmq. So we have to find the number of mole of methane that is represented by this particular volume. So this is how we do that. And when you cross multiply, that will be 7.5 divided by 2.4, and that's 0.334 mole. Now, from the reaction, from the reaction, 2 moles of oxygen was used. So you can see here, 2 moles of oxygen was used to burn this volume of methane. Right? So, therefore, the number of mole of oxygen required to burn our 0.334 mole of methane is equal to 2 multiplied by 0.334, and that is 0.670. Now, back to this our molar volume. Remember, molar volume 1 mole is equal to 2.4 km. So, if 1 mole is equal to what is the equivalent of 0.670 mole? That is the volume represented by this number of moles. So 0.670 is equal to unknown volume. So again, if you cross multiply, the unknown volume is equal to 0.670 times 22.4 km cube, and that is approximately 15.0 km cube. 15.0 km cube is option C. Option C is the correct answer to this question. Okay?
increase your salary next month. After paying you this one, as we agree, next month we'll start paying you 30,000. So we like what you're doing, we like the energy you're bringing in. So you continue doing like that. You can continue taking better care.
Thank you.
You're welcome.
Monday.
Thank you, and please subscribe to this channel for more videos and more parts of this channel. Hello and welcome. I'm going to be answering why 2020 chemistry objective task question strategy. When 250 centimeter cube of a saturated solution of copper 2 tetrasulfate 6 at 30 degrees Celsius was evaporated to dryness, 5.0 gram of the salt was obtained. What is the solubility of the salt at 30 degrees Celsius when the molecular mass of CuSO4 copper tetrasulfate 6 is equal to 160? A 0.031, B 0.125, C 0.640, D 1.560. So we are looking for solubility. The solubility of this salt, copper 2 tetrasulfate 6. And we are giving some values here, which we'll be making use of. We are giving the molar mass of the salt. We are giving the volume of the solution that was containing the salt. We are also giving the mass of the salt that was obtained when it was evaporated to dryness. So the formula we use to calculate this solubility
Hello, sir.
equal to mass
Yeah, how
Good
is it?
evening,
over
sir.
molar mass times 1000 over volume.
I thought it was not connected
Of
before.
solution,
So what did you say?
Wow.
and then the mass
So I thought your stuff was not connected.
our
Wow.
mass, like we said, is 5
It just
grams.
connected. I just tried to see.
One
Yeah.
times 1000 over volume of the solution, 250 cm cube.
Yeah,
Completely
so we stopped at number 31.
1.5 as your answer.
We stopped
Okay.
at number 31. in fact.
Okay,
We
so
stopped
let's
at
do,
number.
yeah,
Go to our channel for more videos and for more past questions and answers.
let's go to 31. 31, isn't it? 31, okay? Let's go to 31, okay? Oh, yeah, so let's start.
Thank you.
Are you there?
Yes, sir.
Okay.
It said what volume of oxygen at STP is required to burn completely 7.5 dm cube of methane according to the following equation. And it now gives CH4 plus 2 moles of oxygen equals CO2 plus water.
Good. So how do you go about it?
Now she give mommy now.
Hmm?
5 times.
Sir?
That is not
Okay, keep talking to me.
no sir, no sir.
So how do you go about it?
Sir, so
Yeah?
let me I did since we don't know the mole, they said what mole of oxygen at STP requires 7.4 dm cube. So
Yeah.
I did X of O2 gives 7.5 dm cube
Yeah,
of
X supposed
methane.
to give 7.5, yeah.
Yes. Then I did 1 mole of methane give us 2 moles of oxygen.
Yeah.
And I cross multiplied and I got 15 mole per dm cube as my answer.
Okay. But one mole would always contain 22.4 DMQ. So X will contain that 7.5. So make X the subject. It will give the 0.34. But here, one of these gives two of these. So how many will give 0.344? So make that the subject. We'll give it 2 times 0.344, which is this. So this this got an answer 0.67. How many DMQ does it contain? Since 1 mole contains 22.4 DMQ, so multiply out to give you 15 DMQ. But the method you use, you get 15.
I think I prefer your own.
You prefer
Yes.
my own?
Yes.
And I write it out. Let's start from here. From 18, 1 mole is supposed to contain 22.4. Okay. So how many mole is
I used the equation to find it.
Okay. So check
yes,
this one.
I did 1 mole of methane and 2 moles of oxygen.
Yeah.
Then I wrote 7.5 DMQ for methane and X for oxygen.
Yeah, but that does not contain the whole of the information that is required of you. So 1 mole at STP should contain 22.4.
So I can see the down.
Okay. Which side is it? This side. This side is 0.07. This one says 1 mole contains 22.4 DMQ. So 0.670 will contain how many mole? X. So making that X the subject, so now be 0.67 times 22.4 DMQ to give us 15.0. In case you don't see anywhere you talk, and I should done it. So do we move forward?
I'm coming.
Yeah.
So why did we do 0.334 times 2?
We did that because 1 ethyl normally gives 2 mole. 1 mole ethyl will give 2 mole of this. But here we're not having 1 mole of ethyl in this case because the mole is 0.33. So 0.33, how many mole of oxygen will it give us? It will give us 0.67 moles of oxygen. So this 0.67 moles of oxygen, what volume does it contain? Since 1 mole of oxygen contains the volume of 22.4. So we went from solving for ethane to solving for oxygen. By knowing the relationship between ethane and oxygen, here it's 1:2. So this was for ethane. We are simply saying that 1 mole of ethane at STP contains 22.4 DMQ. So how many moles contain 7.5? Since it's 7.5 that you're considering, you're not considering normal 22.4 for 1 mole. So that mole that contains 73.5, what amount of oxygen will it consume? Since 1 mole consumes 2, so this 0.33, what will it consume? It will consume 0.67. So that is the mole of oxygen needed here. And since 1 mole has a volume of 22.4, that mole, which is 0.670, what volume does it have? It has 0.
Okay, so we can move on.
Yeah. Make sure you write it the way I wrote it here, so that when you read it later, it will make better sense. You understand?
Yes. They said 2 moles of oxygen was.
Okay. Let me get back. Okay, so let's start from here so that you understand it. Are you looking at? Are you looking
Yes,
at?
I'm looking. Yes, I'm looking.
So we'll start by saying that at STP, 1 mole is supposed to contain 22.4. 1 mole for methane, 1 mole is supposed to contain 22.4 dmq. But we are not looking at the volume of 22.4, we are looking at the volume of 7.5. So we say X mole will contain 7.5. So we want to know the number of mole that is in this 7.5. And that is the number of mole that we use in reacting with this oxygen. For 1 mole reacted with 2. So that number of mole now will react with how many oxygen? That's what we say.
Oh, they recorded it.
So the volume of methane now is 0.334. That is inside the 7.5. This is the 7.5 that went into reaction, not the 22 point. So we now say for 2 moles of oxygen, since 1 mole of methane gives 2 mole of oxygen, this 0.334 that went into reaction, how many mole of oxygen will it give? And that's 0.67. So it's asking now, how many will it give? So when you cross multiply now, you get that 0.67. So you can see where I wrote from the reaction, 2 moles of oxygen was given by 1 of methane. So how many oxygen will 0.334 give? So when you cross multiply, you get 0.67. So this is the actual number of oxygen that it will give. But we all know that 1 mole contains 22.4. So this mole now, which is 0.67, what is the volume of this mole? So if you call it X and make it the subject of the formula, when you cross multiply, it will give you 15 dm. So you can see 1 mole gives 22.4, but this 0.67, how many gives unknown? So make this unknown the subject. So you now have 0.67 times 22.4, which is 50.
But since the 0.670 is representing methane, why is it not just 1 mole? Like it will just be 0.334. Since it's not oxygen, is representing.
You mean this 0.33?
Yes.
This
Since it's for
0.33
methane, not
now,
for oxygen.
yeah, this 0.33 now is the mole of methane that went into this reaction. But we all know that 1 mole of methane will always react with 2 mole of oxygen. So this 0.33 mole, how many moles of oxygen will it react? That is this 0.67 mole of oxygen. So what is the volume of this 0.67 mole of oxygen? That is 15.0 dm.
Okay, I now understand.
You understand, Bob?
Yes, sir.
So it's somehow tricky, but it's molar calculation. That's the way it normally is. So let's go to 32. I'll read it out.
When 250 cm cube of saturated solution of CuSO4 at 30 degrees was evaporated to dryness, 5.0 grams of the salt was obtained. What is the solubility of the salt at 30 degrees Celsius? And they gave us CuSO4 at 60.
So in this one, you simply use the formula mass over molar mass times 1000 over volume, Abi.
Yeah. Yeah, I got 0.125.
Was that what you got
125.
What did you get as well?
0.125 mole per joule.
Okay, 0.125. So this one is pretty straightforward. Abi?
Yes, sir.
Okay. So let's check out
Number 33. The bond between NH3 and H+ in NH4 ammonium is A daisy bond, B covalent, C hydrogen, D electrovalent. Answer is A dative.
Daisy bond, yeah. Daisy bond.
Daisy bond.
Whenever you have complete your ammonia, you have extra oxygen coming to it. Call that daisy bond. Coordinate covalent bond involves sharing of electron. However, the electron pair that is shared is donated by one of the participants. So there is a sharing of pair of electrons. Okay. We all know what covalent bond is and what. Okay. So ammonium is normally daisy bond. Just take note of that. It's likely gonna be out there for you. Which of the following oxides has a giant covalent structure?
So I put C.
Hmm?
I said I put C.
Okay. So what is giant covalent structure? Giant covalent structure is simply an atom that contains many atoms that are joined to adjacent atoms by covalent bonds. So we talk about plenty covalent bonds joining and joining atoms. So that is what we call giant covalent bond. And the atoms are arranged in regular lattice. Okay. So for A, we have what we call hexagonal crystal lattice. And similar to what we have in B for O10. For D, here we have silicon oxide. That's actually why we have giant tetrahedral structure, which is an example of giant covalent structure. Okay. So you picked D.
Yes, sir.
So that is the answer. Okay, so let's move over to the next one. Next one is 35, isn't it? Which of the following hydroxide is not readily soluble in water? So which one? This one is very simple. Now it's calcium hydroxide, have you? What did you pick?
Yes, sir. I put calcium hydroxide.
Yeah, because the other ones are very sodium and potassium. They are very, very soluble. You know, they are alkalis. So they are very, very soluble in water. It's only the hydroxide of calcium that is, and those of normal metals are completely insoluble. Okay, so let's move forward.
So,
Yeah, you're saying something.
and NH4 is soluble in water too.
Very, very. Ammonium hydroxide is also very, very soluble in water. It's ionic. All of them are electrovalent kind of compound.
Interesting.
Which of the following statements about solubility of salts is correct? Oh, yeah. Which one?
So all compounds are ionic are soluble in water.
Yeah. They are polar, very soluble in water.
Okay, sir.
Okay, let's check out 36.
Number 36. Which of the following statements about the solubility of salt is correct? A. Salt whose solubility increases with temperature will not crystallize. Salt whose crystallization will be efficient in separating out a salt whose solubility increases considerably with temperature. D. Solubility of the solid does not affect crystallization. Number 30.
So move to 37.
I didn't hear you.
You said number what?
36.
It is 36 now, huh?
Did you hear what I said?
No, you said the answer is what?
Let's see. So I said the answer is C.
Yeah, I see, because one is that this number D cannot be true. Solubility of a solid does not affect its crystallization. This cannot be true because solubility affects crystallization. Also, salts are their temperature, their ability to crystallize depends on temperature. So it makes these two very eliminates them. But this one crystallization will be efficient in separating out the salt, whose solubility increases considerably with temperature. Yeah. So once it crystallizes at lower temperature, then it gets separated out. So C is very, 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 very correct.
So why did you say A is not correct?
It says a salt whose solubility increases with temperature would not crystallize easily on cooling.
Okay.
It will crystallize once you cool it, because its solubility is very high at high temperature. The solubility will be very high at high temperature, so it will be fully dissolved in the solute. But once you reduce that temperature, because temperature is affecting it, as you're reducing the temperature, it's crystallizing out immediately. But yeah, you say it will not crystallize out, so it's false. It has to crystallize out. Substances that have their solubility dependent on temperature, once the temperature is increasing, they will be fully in solution. But once the temperature is decreasing, they will crystallize out of the solution.
Okay.
You understand? Yeah. So C is the right answer.
Then we can go to the next number. Then we can go to the next number.
Next number,
Mm-hmm.
is 36, but how many moles of H2SO4 are there in 50 cm cube of 0.1 dm cube solution of the acid?
This one I chose D.
B, bro.
Is it?
D.
Yes.
Why? The same formula.
Because I did concentration is equals to. Yes.
Okay. So how many moles of
So I got 5.4 times 10 raised to the power minus 3 as my answer.
So let's move forward. So let's try let's interview. If 20 cm
Yes, sir.
cube of hydrogen was characterized by this, what's concentration of this? Okay.
Yes, sir. You just have to use the formula to get it. I got
Let's
0.02 mole per dm cube.
Okay, so let's get to 39. I will have a meeting with somebody by when we get to the 40 question. Huh? So let's
40.
quickly get to 40. Yeah,
Okay, sir.
somebody is waiting
Number
for me.
39.
Yeah, 39. Electrons always occupy the lowest empty energy level. The statements of who? About
Absorbance, above 50%.
Pauli exclusion and periodic flow.
The
So what's the
one
answer?
says that they pair first. About. Please. So the answer is A.
Okay, is it about that says that they must occupy the lowest energy level first before the higher energy level?
Yes, sir.
Okay. So what of Hunt's law and Pauli exclusion principle? What were their, you know their statement?
Yes, I do.
Okay.
The Hunt said that electrons must pair singly first before pairing.
Okay.
While Pauli's exclusions was saying no two numbers can have the same 4 quantum. Did you hear me? Hello? Ah. I am it,